This is 301.1 Force Concepts problem set in My Open Math. I'm going to click through the problems starting with number 1. Again, these are randomized, so you may or may not have this exact scenario on yours, but the question says Corey pushes a desk across the floor as shown. Which free body diagram most correctly shows the forces acting on the desk? And so again, in this situation, when you're doing a free body diagram, you have to first of all identify the system, and it's identified in the question. What are the forces on the desk? And so after you have the system identified, you then have to determine what forces are acting on that system. So what forces is the desk experiencing? Obviously, Corey is pushing it, and you can see that that is represented here by this red arrow showing an applied force from Corey on the desk. But that's not the only force acting on the desk. If you look at our answer choices, we have some different options down here. Many of these include the applied force, which is yellow in these pictures, but some of them also have Fg, that is the force of gravity or the weight, Ft, which would be the tension if there is tension, Fn is the normal force, again if you have normal force, and I think those are the only forces that are here. So in this scenario, what else is happening apart from just him applying a force? Because there isn't really an option here that shows just a free body diagram with an applied force to the left. And so the other forces that we need to include that are acting on our desk are the force of gravity. The earth is pulling down on the desk, giving the desk its weight. Force of gravity is always going to be present in our free body diagrams so long as we are on Earth. Okay, or on any planetary body for that matter. And so we do need Fg pointing straight down. The other force that we need to include is we need to include the force of support from the floor. That is called the normal force. The normal force is the reason why the desk isn't in free fall, because if you did not have an upward force, this desk would be falling. So looking at our options, like this one, for example, just includes the applied force and gravity. This desk would have a net force in a downward diagonal direction, meaning it would be falling and accelerating to the left. We'd have acceleration like this. We don't have that situation here. It's simply being moved horizontally across the floor. So we need to choose a diagram that shows both an upward and downward force like this one. Force, normal force of gravity. And these two right here are going to mean that rather our desk isn't going to accelerate vertically at all. Rather, it's only going to be accelerating in the horizontal direction to the left, and this is actually the correct answer for the scenario that we just looked at. There is no tension to include here. Again, if you see tension, you're looking for a rope or a string or a cable, something like that. We don't have that in this scenario. Next question, number 2 on 301.1 says Mike lifts a box from the ground as shown. Which free body diagram most correctly shows the forces acting on the box? Again, we can see that he's lifting it, so we know he is applying a force to this box. We also know, just like the last question, that we always want to include the force of gravity. This box has weight to it. The earth is pulling down on it, giving it weight due to Earth's gravitational field. So we have an applied force up and we have force of gravity down. Again, if we start looking at our options, I can see those two are labeled here, but this one also includes tension to the left. And there's nothing in this diagram or description that would imply that there is any force of tension to the left. I don't have a rope or a string or a cable or anything like that. This one has normal force to the right, which again does not make sense for the scenario we're looking at. Applied and gravitational does. Again, I didn't see anything happening horizontally. I just saw the applied force upward, and the weight would be directed downward. And again, no tension is present. The normal force you would only include if you were on a surface that's pushing back, and again, we don't have that either. So I'm going to go with the one I've already selected. Again, this one right here. Question 3. What is the weight of an object with 29.5 kilograms? So if we take a look at this, we're going to be putting the magnitude of the weight here. Again, remember Fg is weight. And then we are going to specify the direction below that. So We have an equation for weight. The equation that we use for weight says that the weight of an object, or its force of gravity acting on our object, is equal to the mass of the object multiplied by acceleration due to gravity. Again, remember on Earth, this value is negative 9.8 meters per second squared. And so if I wanted to determine the weight of an object with a mass of 29.5 kilograms, and I know that's a mass because of the units, then all I need to do is multiply 29.5 times 9.8, mass times gravitational acceleration. And so if I do that, 29.5 times negative 9.8, I do end up with a negative number, negative 289.1. However, the question only wants the magnitude, 289.1. I'm not going to include the sign here. My unit for all forces, including weight, is newtons. The direction that I need to choose is the downward direction. Again, that's what that negative sign represents on my calculator. Okay, but it means that weight is always downward. We're always going to have a negative in front of it if we include that direction, because forces are vectors, forces have direction, and the force of your weight, or the force of gravity pulling on you, is always downward, or Earth pulls you down toward the surface. That's question 3. Question 4 on 301.1. What is the mass of an object that weighs 9,925 newtons in the downward direction? And again, weight is always downward, so I would expect to see that pointing that way. I'm looking for mass. I get to use the same equation that I just used a minute ago. Weight, or Fg, is equal to mass times gravitational acceleration. So this weight, 9,925 newtons, equals the mass, which is what I'm trying to find, times gravitational acceleration, which is negative 9.8 meters per second squared. In order to isolate this variable, these are currently being multiplied. I need to divide both sides by negative 9.8. Okay, and that cancels here, and so this is what goes in my calculator, just the numbers. I put the units over here so you could see how we get our units, but you can't see it if it's written as newtons. I'll talk about that in a second. First, let's go ahead and divide this. Oh, I forgot one thing. It is a downward force. It says so in the question, 9,925 newtons down. So I do want a negative sign here. Those will cancel, leaving me with a mass that is a positive number. And it's not actually that it's positive or negative mass, it's that mass doesn't have a direction at all. It is a scalar quantity. But let's go ahead and divide 9925 divided by 9.8. I'm ignoring the signs altogether because I don't need them whenever I'm recording my mass. Okay, and so the mass of the object is 1,012. If I round this to 2 decimals, that becomes 7.6. The units will be kilograms. And again, mass is scalar. It has no direction. Okay, so that is how you would answer that question. Number 5 on this same assignment, 301.1, if your weight is 568.4 newtons and your mass is 58 kilograms, how would those values change if you were on the moon? Note that the gravity on the moon is 1/6 the pull of the Earth. Okay, we talked about this in our notes, but again, your mass is always the same value. Okay, mass is the amount of matter in an object. The example that was in the notes was a bag of Cheetos. If you brought a bag of Cheetos with you to the moon, assuming you didn't eat it on the way, you'd have the exact same amount of mass in that bag, whether you're on Earth or on the moon or in the space station or wherever you are. The mass is not dependent upon the location. It doesn't depend on the gravitational field strength. And so if the mass is 58 kilograms on Earth, then the mass is also 58 kilograms on the moon. However, weight, Fg, is mass times gravitational acceleration. And if your gravitational field strength changes, and that means your gravitational acceleration changes. That means you have a different weight. Again, the mass will stay the same, but the weight will end up different. And so if you have 1/6 the gravity, you would have 1/6 the weight. The question says that your weight is 568.4 newtons, so I will do 568.4 divided by 6, and I get this value here, 94.73 newtons. Now, again, weights are normally negative numbers, so it should accept this whether you type a positive or a negative. Since the weight is technically a downward force, it would have been probably more correct for me to do that, but oftentimes I will specify and ask for the magnitude of the weight, in which case this would have been an acceptable answer, but it was acceptable regardless. As I said, I believe it takes it either way. Number 6, 301.1, true or false? Mass is a force. False. Weight is a force. Mass is not a force. This is number 7. It says, what force is the result of a solid surface pushing on an object supporting it? Again, if you look at anything about support force, that is the definition for our normal force. The next one says, what is the force of pulling a string or rope? Again, if you see string or rope, I want you to think of tension. The next one says, what is the force otherwise known as the weight of an object caused by the earth? The pull of earth on you is that gravitational force. It gives you your weight. The next one, what is a force that is any push or pull that doesn't fit into any of our other categories? This is the applied force. Typically the question will say, Tom pushes a box with 5 newtons of force to the right. Okay, and so the applied force is oftentimes applied by a person, but again, it could be any push or pull. It doesn't have to be from a person, and it won't fit into those other categories typically. What is the restoring force that a spring exerts on an object as it tries to get back to equilibrium? Again, this is, and I'm sure the name gives it away, going to be spring force. However, it doesn't have to be a spring. It can be anything elastic. Okay, but when we talk about spring force, I have a rubber band right here. Okay, if you stretch this, it wants to return back to its normal shape. In fact, if I let go, it does just that. Okay, and so the spring force is the force that wants to pull it back into equilibrium to its regular shape, whether you're talking about a spring or any other type of elastic object. Gravitational force always points straight down towards Earth. Frictional force always points in the opposite direction of the motion along the surface. Again, those are just definitions. All right, let's go ahead and look at question number 8. Question number 8 in 301.1 says an object has just been dropped straight down and is in free fall. Which of the following could be an appropriate free body diagram for this situation? We just did a unit on free fall. It was in our acceleration unit. And part of our definition of free fall is that an object is in free fall when the only force acting on it is gravity. And so that's the only force I should see in a free body diagram for something in free fall, is the force of gravity. That's it. Okay, so we're just going to pick that one right there. All right, last question, number 9. A book is at rest on a tabletop. Identify the appropriate free body diagram for this situation. Again, if I take a look at this book, there are different forces acting on it. One of them is gravity. It's always there. Every single free body diagram here has it as a choice. However, the other force is the support force from this tabletop. And that support force has a name, and it is called the normal force. Picture D shows gravity down, normal force up. I don't have anything here involving friction or an applied force because it's just sitting there at rest. And so the answer we're going to select is answer D, normal up, gravity down. That is it for this assignment 301.1. Hopefully that helped. If you have questions, please make sure you're asking them in class.